everyone. Welcome to today's class. In previous class, we learned how to create a frame model by using the grid system, by entering the nodes, and by using the structure wizard. We also learned how to use the translational repeat, the different supports in STAAD, and how to assign them. In today's class, we will be learning about beam analysis. So for this, let us take a problem. So find the shear force and bending moment of a singly reinforced concrete beam with the following data. Assume M25 grade concrete and Fe415 steel. So here the clear span is 4 meter, the width of the support is taken as 230 mm and the live load is taken as 4 kN per meter. Now let us see the manual calculation. Here the effective depth is taken as clear span by 20. So we'll be getting 0.2 meter. Then we had adopt the effective depth as 210 mm and the overall depth is taken as 250 mm. So the effective span is calculated by clear span plus D. That is nothing but 4.21 meter. Now to get the self weight, the formula is volume into density. So that is nothing but 4.21, that is the clear span, into 0.23 is the width of the support, and then we have the 0.25, that is the overall depth, and 25 is the density of concrete. So we will be getting it as 6.05 kilonewton. Now this self weight per meter is calculated as 1.4375 kilonewton per meter. Now the total factor load is 1.5 into dead load plus live load, which will be obtained as 8.16 kilonewton. Then we have the shear force, that is nothing but 17.17 kilonewton, and the bending moment is obtained as 18.07 kilonewton meter. Now let us do the same problem in STAAD and verify the answers. So for this, go to STAAD, create a new project. I'll be choosing plane here. Let me give the name as singly reinforced beam. Here I choose the units as meter and kilonewton. Next, I choose the option add beam, finish. So here, first I'll be drawing a beam of length 4.21 meter. So for this, go to add beam. Now let me assign simply support on both the ends. So the simply support is nothing but the pinned supports. Go to create, pinned, add. Now I'll be using the cursor to assign these supports. The next step is to assign the cross section to the member. So that is nothing but here we'll be taking a cross section of 230 mm by 250 mm. So for this, go to commands menu, member property, prismatic. So this prismatic option will allow us to create structures of rectangular shape, circular shape, and so on. So we can either go to this option or else we can directly go to general property and here define. Here choose rectangle. Under the depth I'll be taking it as 0.25 meter and the width is taken as 0.23 meter and the material is chosen as concrete. Add. Now I'll be assigning this property to the section. Next, I need to change the concrete density to 25. So for this, go to the STAAD editor. Here, if you scroll down, you can see density and just type it as 25. Then save it and close. The next step is to define the loads. So for this, go to General, Load and Definitions. Here, under load cases and details, add two cases. The first one is dead load and the second one is the live load. Now the self weight is assigned to the dead load. So choose self weight. The factor is given as -1, add. Next, under live load, we will be giving an UDL of 4 kilonewton per meter. So for this, choose the live load case, add. Here, under member load, choose uniform force. We also can see the different types of forces that can be assigned to the member load, like the point loads, UVL load, trapezoidal load, etc. So here we need an UDL. So go to uniform force. Under W1, as we need it in the downward direction, I give the negative sign with 4 kilonewton per meter. Add. Now, if you see under these loads, we find a question mark. This means that the load is not assigned to any of the member in the structure. So, I'll be assigning the self weight as well as the live load to the entire beam. So choose the self weight, assign to view. Now this symbol indicates that this load is being assigned to the structure. Similarly, the live load is also assigned to the member. Next, we need to create a load combination. So for this, go to command. Here under loading, we find the load combinations. Now just move all the load cases to the right hand side, and here I'll be defining the load combinations with a factor of safety of 1.5. Add, close. Next, we need to analyze it. For this, first go to analysis or print, choose all, add, close. Now once this has been added, analyze the member, analyze, run analysis. Now you can see that there's no errors or no warnings. Here instead, the warnings can always be neglected. Now I want to view the output file. Done. Now in this output file, I can check the self weight is -1 and the actual weight of the structure is 6.052 kilonewton. Now to see the shear force and bending moments of the member, just double click on the member. Under shear bending tabs, choose the load combination that was created, and to view the bending moment, click on bending Z, and to view the shear force, click on shear Y. Now you can see that manually the shear force was calculated as 17.17 kilonewton and bending moment was calculated as 18.07 kilonewton meter. And also instead we have the shear force as 17.17 kilonewton and the bending moment as 18.07 kilonewton meter. So guys, we come to the end of this class. So in this class, we learned how to carry out the beam analysis. See you all in the next class. Thank you.